Mr. Lobo. So the goal for the final fall project was to create a new and improved product while implementing the engineering and design process. So I chose to go with a tic-tac-toe board, as I saw this is a product that could use some improving, because after conducting some research, I found they tend to be overpriced, over manufactured, and they kind of just are boring and they need some spice to them. So my goal was to create a better version where I could mass produce a tic-tac-toe board by using engineering and design problems and solutions that we have learned over the course of many years of Lobo's classes. So the goal for my board was to construct a visually pleasing board designed for the homes of young families, as board games tend to be better marketable towards families with young kids, siblings. So my criteria I put on myself was aesthetically pleasing. I chose this as one of my main pieces of criteria because I don't want some crappy looking board in my house. I want it to be something I would be proud to keep on my kitchen island or my dining room table or a coffee table in my living room. Something that I can use for both aesthetic purposes. It looks nice. Maybe I can put a cup of coffee on it or a vase or something, some books, but also something that kids could use. I would like it to be easy to move. I used to lose pieces of games and toys all the time. I don't want this product, as we're trying to improve it, I don't want it to be losing pieces all of a sudden. People have to order new ones just because there's too many moving parts. Another piece of criteria was production, affordability, and uniqueness. There are some other ones on the market that all kind of look the same and do the same purpose, which it's a simple purpose of tic-tac-toe, but my goal was to create something that's unique, something that catches people's eye. And of course the deadline, that was a while back. So constraints that we have to take notice of were size, weight, pieces, and assembly, which we already talked about, and the difficulty. So size and weight, we don't want this to be something as huge, as we want this to be marketable towards kids as our business would progress and we produce more and more and sell more and more. And that would be on the actual engineering part of it, which would be my part. So I can design a easy to manufacture board that is easy to move and aesthetically pleasing to everyone. So those are my criteria and constraints. As we move to inspiration, after conducting some research, these are what the most common, I should say average board would look like. They have many moving parts, usually do not have a top cover lid, and they kind of could just end up pieces falling everywhere. They look like a tic-tac-toe board. They don't look like a cutting board or some piece of decorative furniture. So I really wanted to try to implement a more aesthetically pleasing and homey feel into my board I'm making. And also, this goes for the engineering design process. I don't want nails and screws. If I was a kid or a parent with little kids, I don't want that danger. It also adds a lot of extra weight to those big pieces of metal, and it would take away from the aesthetics of the board, how it would look in your home board. So I chose dowel joints, as they provide a pretty much seamless and very easy level of jointery to produce the boards in. And they also would be able to easily manufacture, as they're a very simple joint. They're not something like dovetail or even more complex. So here are a couple of my original sketches. So as you can see with the sketch on the left, I kind of sketched out my whole design for the board, how it would have a reversible lid, where one side would be the actual board itself, and then you could flip it over and just have some sort of decorative piece where maybe you could put some books or a vase or a candle, as I said earlier, and you'd be able to store the pieces inside of the board, so you would never lose any of the pieces. And to the right, those were some of the original ideas of different ways I could create that, compared to the ones we looked at earlier from my inspiration. But overall, I went with the photo on the left, my sketch. and started building in Fusion 360 off of that idea. So decision time. I kind of explained it in the last slide, but here was my decision matrix. I did it golf style, lowest points wins. So I did decide that rounded corner slab board with lipped pieces would be the most affordable. It would hit the deadline, size, difficulty, everything. It checked all the boxes compared to other boards that I looked at previously and drew previously. So as we go into Fusion 360, which is a engineering software that we've been using and practicing on in Lobo's classroom for the past couple of years, it helps create and visualize different parts of the engineering process while creating items. So here is what I intend the board to look like. It has a cover with a flat side and a lipped side that will be the actual game board itself, and it has a tab where you could stick your thumb and flip it easily, where it's going to be a light piece of wood, as the stock we have in the classroom is, I do forget what kind of wood, but it is very light and would be very easy to manufacture due to its price. And on the right, there is what the actual board would look like assembled after taking a router to the sides of the 4 different pieces after they are all jointed together. And for the bottom, it's going to have a sliding, it's going to be the same material as we used at the top. It's going to be a little lips on each of the sides of the game pieces, or the board pieces, I should say, and you will be able to slide it in and then dowel joint it shut. So it is a secure piece of board that has very low chance of breaking. For our stock, we went with a 1.5 by 12 inch birch plywood, and I chose this because of its affordability, its strength, its weight, and its cost, which I already said, but affordability, cost, same thing. But per square foot, this would be the most easily affordable for an actual business model, and we could also sand it down, cut it easily, and would be able to also stain it, so it would be even more aesthetically pleasing to the eye of a family. So for the piece, instead of going for X's and O's as original game boards for Tic-Tac-Toe have, I decided to add something unique to this, where this could also be very customizable at maybe a different price. This could be a couple dollars extra on an actual business model. So I went with the previous Super Bowl game of the Chiefs versus the Eagles, and I designed a wooden cutout where you would put in a 3D printed insert, glue it in, and have that be the logo. This would be just about 2 inches wide by 1/2 inch tall for each of them, and this would provide customization and uniqueness to the board, pointing it out from other boards that are currently on the market. So this business model would have a better chance of succeeding due to this customization. For the manufacturing part of the actual board, after we 3D printed the pieces and we implemented them into the design, the board itself and each of the sidewalls will be manufactured on a CNC machine. So if you don't know what a CNC machine is, it's a little drill bit that moves really, really fast and spins really, really quick that perfectly cuts out whatever you program it. We programmed it with Fusion 360, a online CAD model, to where we could program whatever lines we want cut out, how deep we wanted it, and this provides accurate and precise cuts on the machine, and it would also be able to manufacture easy in a factory, as the machines are very popular. So for implementing the engineering and design process, I should say, once I get my business partners on this incredible idea. So creating the sketches, we had to start somewhere, got to brainstorm. We printed scale versions to see flaws and weaknesses to change. I started with some 3D printed models, about 3 times less scale of what I wanted the board to actually be, just to see how it would function, how it would move, where I could change something, where I could do better. And then I went back to using the application of Fusion 360 to make those changes. So, and then after a while of discussing with peers and our teacher, Mr. Lobo, I finally, I should say, got to my final piece, which would be a couple side pieces that we use on the CNC machine, and it provides an easy to manufacture, affordable cost, and very producible tic-tac-toe board. And after all that was said and done, the improved designs to match the theme, aesthetic, and the game of the board, that I can say as the pieces being easily customizable, unique to any other boards on the market, and just add an overall level to the game that provides customization. It's unique, it's personal to the actual buyer, which is why I think this model of a business of a game board would be very, very successful if I launched it as a real company. So bringing the design to life, the by-dowel was to make the board, bevel the edges of the board, which would use some sort of router table with a very, very fast drill bit that will curve the side edges to not only make the game board more aesthetically pleasing, will also cut down on weight a little bit to move as it's cutting wood, and it creates a little bit more safety with young kids as there'll be softer rounded edges instead of hard corners. So, as of right now, I am undecided if the game board will be stained. I believe it should be, but that could also come at an extra cost. So CNC the pieces of the frame, we've already talked about that. The logo inserts will be 3D printed. I've already done that and painted them, so those are all set. And then put everything together, bam, we have our first actual board. We have not done that yet, but we are currently in the process. And